This is looking at solving problems using vector geometry. Just so you know, these can get rather difficult. I'm not going to go into too much detail. I'm going to just focus on the more simpler problems for this with vectors. So I'm going to start off with an example here. I've got a triangle. So that is PQR. Now, I know that PQ equals Y and PR equals X. M is the midpoint of QR. And then we got our question here, what we have to do. There's actually a third part as well. Now, before we go on, diagram's not to scale. Second thing, notation, just to realise, the capital letters are our points that we travel along. So M's, well, that's meant to be a capital there as well. So PQ is how we represent the direction that we're going. So PQ is from there to there. That's the arrow on top. So PR, so that's from there to there, arrow on top as well. So this direction here, QR, which is actually the first question, is going from there to there. Okay, capital letter, start point is a Q, end point is the R. Okay, the lowercase letters you find on these questions are your vectors, your directions that you're going. So you're going from there to there. Okay, now I'll do this through the examples to help you with it. One way I like to think of them is you want to give directions, for example, Q to R, but you know to get from Q to R is that way there. But you can't just travel that way there. You need to only take routes that you know. And the routes that you know here, because we have Y for that direction, we know that route. And because we have X for that direction, we know that route. So we can't directly travel that way because we don't actually know what vector, what this value will be here. So if we're looking at traveling from Q to R, we need to look at what routes we actually know. So we don't know this there, but we know that way and that way. So we have to travel backwards along this line here. So we're actually going from Q to P. And then from there, we are going from P to R because we actually know that direction there. So P to R. So if we take the directions that we actually know, we know that Q to P is minus Y because we're going that way. And then P to R is plus X. So that will be the direction you take. You can write this the other way around. So you can write X minus Y is that solution. Okay, so that's this direction. Now, the next one we want to look at is going from Q. So Q here, and we want to go to P. I'll draw this one on for you. So we want to go that way there. So information that is not to P to M. Information that we have, M is the midpoint of QR. So it's halfway between here and here. So it's the middle. Now, quite often with these, you can use information from the previous question or the previous part of it. So the previous part here was finding out that QR. So we already know that QR is minus Y plus X or X minus Y. And we want to calculate half of QR. Why? Because it's the midpoint of this line. QM is the midpoint. So we'll take our values here, so minus Y plus X. And what we can do, there's two ways you could do it. You could simply write it, write half with some brackets, and that means half of everything. Or what you could do, you could write minus Y plus X over 2, just signaling that you're doing half that previous distance there. You can write it x minus y as well. It's just showing you how you represent it. But that would be, this or this would be your answer. Now, final part here is you want to look at going from point P to point M. So point P is here, and we want to go to that point M. So we want to go this way, up there, and then down there. Okay. Now you've already done some of the work for this question, because break it down to what you know. Directly is that way, but we don't know that route directly. So we have to take the route we know. We know we can go from P to Q. So we know that route there. Okay. And we now know the route of Q to M. So Q, M. So we know those two routes there. Now P to Q, we know that because it's Y. And then we want to take the next part, which is Q to M, which say we'll take this one here. So we want to then go plus half minus y plus x. Now this point here is probably wise. We want to actually simplify our answer, so we're going to expand this bracket here. So that'll be y plus, now let's expand it. So that's going to be 1/2 y, or minus 1/2 y, plus 1/2 x. Should we do that? And now, because of collecting like terms, you can simplify that answer. So y minus half y gives us half y, add half x, and that will be your answer to this. You can write it as y plus x over 2 or x plus y over 2 as well. But that's how you would find the P to M part. Alright, I've got a second example here. You might want to pause it and try and give some of it a go before moving on. I'll talk a little bit about it before. So it is a regular hexagon. We know that OA is 2x and OB is 2y. Now, that's the information you know. Because it's a regular hexagon, that means that there's several lines that are the same. So that means OA is actually the same as DO. Same length, same magnitude. EF is also the same. CB is also the same. So we've got a few lines the same there. Same with OB. That's going to be the same as OE. And then we also got here FA. It's the same as this OB. And DC. So there are lines that are similar here. Now there's, I think 6 different ones to find. If you want to, you can give it a go, but I will go over them in one moment. All right, let's start looking at this then. So we want D to A. D to A. Now, I did say already that D to O is the same as O to A. So D to A is going to give us D to O, which we know, plus D to A. O to A. So that is going to be 2x plus 2x, which is 4x, and that is our vector, our route that we know. If we look at the next one, A to B, so we can't just go that way because we don't know it. We have to go from A to O and then O to B. So we're going A to O and then we're going O to B. So with that there, we know A to O is going to be minus 2x, and O to B is going to be positive 2y. Okay, or it can be 2y minus 2x. Can be either direction. Okay, let's look at the next one here. So we've got this direction, which is f to b. F to b. Now, this one can use more than one different way. So f to b, you can travel, we have a look, I'll do this in blue colour. We could travel this way. Okay, so backwards along that, because we know that matches up with this line. And then we could travel all the way up. Or we can travel up there, down here, and up there. Let you know that either way will result in the same answer. So I'm going to look at the first way I said, that way, and then all the way up. So I know here f to e is, because I said about that, it's minus 2x. And I'm going all the way up, so it's going to be 2y for that part, and then that part as well, so add 2y. So if you collect your terms, tidy it up, so you've got minus 2x, add 4y, or it can be 4y minus 2x. It could be one way or the other. We look at the next one here, we've got b to c. B to c. Now, that's going from that point to that point there. So B to C, we're going that route. Now, with that one, let me change up colours again actually. We know how to go from B to O. Now, we don't know how to go from O to C yet. Remember I said about lines being the same? We know how to go from A to B. So that is the same as O to C. So we did A to B there, which is that here. So we need to then go, we can put that all together. So we're going B to O, and then we're going O to C, which is the same as A to B. So we put this together, B to O, we're going down, so it's minus 2y. And then O to C, we're going, like I said, it's the same as A to B. So it's minus 2x add 2y. So if we tidy that all up, it'll leave you with just, I'll do it underneath there, 2 minus 2x, because minus 2y add 2y is nothing. So using that information now, we want to go B to M. So B to M is here. Oh, I didn't write the information down, but M is meant to be the midpoint of BC. Okay, I forgot to write that down at the start. So if you go in there, that means you're going half of your BC, which you found out is minus 2x. So that is half of BC. So that means it's half times minus 2x. So it becomes minus x. That is a value of B to M. And then we're combining lots of different things here for the final one. So we look at that, we're going from F to M. Now we've actually already done some of this because we know F to B from that there, and then we're going to combine it with B to M. So taking note of that, I'm taking F to B and I'm going to add that to B to M. So take the answers from there, F to B, that was minus 2x add 4y, and then plus B to M, which I got there, which will be minus x. Tidy that all up together, so minus 3x plus 4y, or 4y minus 3x, and that will be your final answer for that one there. So this is solving vector problems using, or solving problems using vector geometry.